Hi students, today I am going to explain what is chromatography. It is an important biophysical technique that enables the separation, identification and purification of the component of a mixture for qualitative and quantitative analysis. So chromatography, this is a very important technique. It is a biophysical technique. So it will help to separate the components of a mixture so that we can identify it and purify it. So it is also used for both qualitative and quantitative analysis. It is based on the principle where molecules in a mixture applied on the surface or into the solid and fluid stationary phase is separated from each other while moving with the aid of a mobile phase. Here there are two phases we can see. One is stationary phase and other is mobile phase. When molecules of a mixture are passed into the from the stationary phase, so the mobile phase will separate the particles. So like this we can separate the mixture. So what are the factors affecting the separation process include, say, molecule characteristics, how it absorbs, how it is partitioned, how the affinity will be there, how the molecular weights will be there. So depending upon their difference of all this, the components of a mixture can be separated. So the components form the basis of chromatographic technique. What are they? I already told there are two phases, stationary phase and mobile phase, and after that the separated molecules. There are different types of chromatography we can see, like column chromatography, ion exchange, gel permeation chromatography, affinity chromatography, paper chromatography, gas chromatography, thin layer chromatography, hydrophobic chromatography, pseudo affinity chromatography, high pressure liquid chromatography. So like this, so many types of different chromatography techniques are there. So first we are discussing about thin layer chromatography. What is thin layer chromatography? So it is an affinity based method to separate compounds in a mixture. So affinity means it will get attracted to that. So it is a very highly versatile separation method. It is used for both qualitative and quantitative sample analysis. It can be used to analyze virtually and the substance class, including like pesticides, steroids, alkaloids, lipids, nucleotides, glycosides, carbohydrates, fatty acids, all these, to separate the different components in all this. This thin layer chromatography is used, in short form TLC. So here the stationary phase is an absorbent material layer, so which is made up of a gel or aluminum oxide coated on an inert. So what we'll do, the stationary phase is a material layer which absorbs like silica gel or aluminum oxide is used, which is coated with an inert phase surface. So which is coated with an inert plate surface, typically like glass, plastic, aluminum, etc. Then the sample is spotted onto one end of the TLC plate. So first we have to take a thin layer chromatography, whatever we want to take, and that we have to spot so on one end of the TLC plate and place vertically in a closed chamber with an organic solvent. So we have to keep an organic solvent. The mobile phase travels up the plate by capillary forces. So because of the capillary forces, this is a thin layer chamber. So chamber in this thin layer chromatography is there. Here we draw a line at the bottom of this plate and a spot we keep and we dip it so that it will not dip. The lower bottom and that spot will not dip. Because of its absorbing nature, because of the forces, it will absorb the liquid phase or mobile phase and the chromatography takes place. So the spotting line on the TLC plate, after that we can see after 5 minutes like this it will be, and after 10 minutes so it will be rising like this. The components are raised like this, and what is the RF value we can calculate, the distance traveled by the component, distance traveled by the solvent. So both we can take their division is nothing but RF value. So these are the steps of the thin layer chromatography. Let's see it. Then when the solvent reaches the top of the plate is removed from the developing chamber. So when it reaches the top, we have to remove the TLC plate and we have to dry it. The separated components appear as a spots on the plate. So and we can calculate the RF, I already told. Then TLC is a form of liquid chromatography containing two phases. A mobile phase, which is also a liquid, a stationary phase, which is a solid. Then difference in these interactions between the solid and stationary and mobile phase enables the separation. So because of the interaction between these two phases, it will help to separate the components of a mixture. Then what is the principle of this thin layer chromatography is the compound mixture moves along the mobile phase via the stationary phase. So the compound will be moving along this mobile phase via the stationary phase, and the separation occurs as per the degree of adhesion. So what is cohesion and adhesion? We know cohesion is when the particles are there, when the same type of particles are there, it is called cohesion. And adhesion is when two different types of particles are reacting together, it is called adhesion. So here because of the particles which are separate because of their interaction, so they will get separated. So the separation process depends upon the how much relative affinity of the compounds towards this mobile phase and stationary phase, how much they will attract to this mobile and stationary phase. The stationary phase is we know that it is a thin layer absorbent coated on a plate, TLC plate, and the mobile phase is the liquid in which we dipped the column which flows to the stationary phase carrying sample with it. So components with more affinity towards stationary phase travels very slowly, and components with less affinity towards the stationary phase travels very fast. So what are the absorbents here we use are inorganic like silica gel, Kieselguhr gujar, aluminum silicate, bentonite, etc. And organics like cellulose and its acetylides, charcoal, activated charcoal, dextran gel, polyamides. So these are all we can use as the absorbents in a stationary phase. Then what are the solvents we use in a mobile phase? We can use petroleum ether, benzene or carbon tetrachloride like this. So how to select an absorbent or solvent? How to select a mobile phase and a stationary phase? So absorbent should not adhere to glass plate. So this absorbent should not be there on the glass plate. It should be neatly separating, and the solvent should be of high purity and the selected based on the nature of the compound to be separated. What type of compound we are separating, depending on that we have to select both the solute and solvent, that is mobile phase and stationary phase. And RF value, we know the RF value, so it indicates the position of migrated spots on chromatogram. So it will indicate what is the position on the spots on chromatogram. In thin layer chromatography, the results are represented in RF value, so which will represent the migration of solute related to the solvent. So we know that RF is equal to distance traveled by solute by distance traveled by solvent. So we know the two values, we can find out easily the RF value. So by comparing it with the standards. So comparison should be made only between the spots on the same sheet and run at the same time. And identical substances will have same RF value and non-identical substance will have different RF values. Then when we see about applications, so it is used in qualitative and quantitative analysis of so many organic compounds, and also to test the purity of the compounds. It is also used to separation of so many lipids, amino acids, sugars, etc. and the identification of compounds in a mixture. So these are the applications of thin layer chromatography. Thank you so much, and in the next video I am going to explain gas chromatography. Thank you.